Welcome back. This is part 2. So we went through the sum program, adding two numbers. So what I want to do now is let's get an average of the two numbers, and then let me show you an issue with this. So we're going to use double, and I'll just call it average. And this time we're going to initialize it to 0.0. Now you can put in 0, that's okay, but you may get a error or a compiler warning that's telling you you may lose data because you're putting in an integer into a double. Don't worry about that, it's no big deal, but you just definitely want to put in 0.0, the semicolon, and then of course you want a little bit of. Now notice I'm not saying two numbers because we're going to add a third number. So let's go into in here and let's get the average. So how many numbers do we have? We have 2. So if you recall correctly, the average is nothing more than the sum divided by the number of elements. So here we're going to do our calculation here. And I'm going to make a mistake. And you'll see that one time it won't be a problem, but another time it will. And the reason being is integer division. Now, I have a complete video on integer division, so that will help you explain more and more and more, and I can do another one if you want. So basically, all we need to do is sum divided by 2, which is the number of elements that we have in here. And then we'll do cout. The average is average. And we'll do an end line again. So let's go and do this and see what happens. So we're going to do 10 and 6 is 16. So the average should be 8. So let's give it a try and see what happens. So the first number is 10, the second number is 6, and the average is 8. Well, that's good. So let's try and run this again. And we're going to do 10, and let's do 7. So the average should be 8.5. So let's see what happens. The average is 8. That's not possible. How is that a problem? And the answer is integer division. So what we're doing here is we're dividing 17 by 2, which the actual answer is 8.5. But take a look. When you do division, notice we're doing an integer by an integer. That always results in an integer. So what'll happen is this will be 8.5 will be the actual answer, but will be converted to an integer, and then it will be rounded off to 8. Because what happens is it's just going to chop off the 0.5 in there. So how do you fix this? There's 2 ways of fixing it. We talked about typecasting, but we're going to talk a little bit more about that in a different video. The answer is really very easy. All you have to do is add a 0 here. And let's run this and see what happens. So now this 2 becomes a floating point or a double. And now we're doing an integer by a double. So now let's see what happens. So let's do 10 and 7. And now we have 8.5. So there's another way of doing the same thing. You can do what's called static cast, but we're going to do a simple way. And let's just put in double. We'll talk more about static cast later because static cast actually is the preferred way of doing it. So what this really means is treat sum as if it was a double. It doesn't convert it to a double, but it does for this equation in here. So now we're going to have the exact same answer. We should have the same answer. So we'll do 10, and we'll do 7, and we get 8.5. So let's go and briefly go through this thing in here. We've added two numbers here together. We've done the average, and then we have first number, second number, third number. So now I'm going to add a third number here. Let's just do number 3. And this is going to equal 0. And now we have a problem. So let's go and get our third number. And we'll do what is third number. And we'll do number 3. Then we need to make sure to update our sum. Did not seem to add the plus this time, so I added, or the space this time. So now we have number 3. So let's go and do this again and see what happens. And then hopefully you can look at this thing and you can see that maybe we have an issue here. So let's go and try the same thing again. And first number is 10, second one is 5, and then let's do the third one is 12. So that should be 15, 27 should be the sum, and then let's see what happens with the average. So the average is 13.5. That can't be right. How can the average be 13.5 if the highest number is 12? And the answer is very simple. So let's go back and take a look at the code and look at our average. Our average is divided by 2, but we have 3 numbers. Now, there's ways to fix that, and which you're going to learn when we start doing arrays, so you never have to worry about this code. So let's go and run this again and try the same thing. So we'll do 10, we'll do 5, and I think we did 12. And that gave us 9. Well, that makes sense because that's 27 divided by 9 is 3. So let's run this again with different numbers. Let's do 10, 5, and we want to make sure that it's a odd number. So let's go and add. Let's, instead of 12, let's add 11. So that should be 26. So now we have 8.6677. So that actually worked. So how do we round this off so it's not such a strange number? So that leads us to the last thing is IO-manip, which is part of your includes, and you'll learn more about that again. So let me actually fix and spell this right. So what IO-manip does, it allows me to set width. It allows me to do a whole bunch of different things in here. But in this particular case, all we want to do is set the number of decimal places, which in this particular case, let's set it to 2. So what we're going to do here is we're going to do a cout, and we have to type in fixed. Now, we'll learn more about IO-manip and all the different things later. For right now, let's just type in fixed, and then we're going to type in set precision. And all we need to do is put in the parentheses how many decimal places we want. So that's as simple as that. And let's go and what is the first number? So we'll do 10. I think we did 10, 5, and 11. And it's 18.67. Of course, it's going to round off because it was 66666 and 7. So it rounded it off in there. If we did 3 decimal places, it would be 8.667. So that's everything for this